This is resolution number 4. Someone requested it, so let's go ahead and talk about it. We haven't done a video in a while, so I need to start doing more. You push the lawnmower sitting down, right? It's on the surface. What's up? FN, right? And then you know you gotta what? FG down, right? Here's the thing you gotta remember. You're pushing down on the lawnmower this way, so that means you want to pull that vector through that angle that way. So technically what happens is this vector goes away, and it's the exact same thing as this vector right here. Let's back that up for just a second. You know that angle right here is 30 degrees from the horizon right here. So by vertical angles, you know this guy right here has to be 30 degrees. What you need to do is redraw this whole picture. Again, look at it like this. You know you have a FN up. You know you have a FG down. Now this vector right here, which is FA, has a horizontal component, which you call FAX, right? And FAY, since it's going down. Let me switch to the pen, so that can be a little neater. Now, since you have that information, you got to go back. It says find the component of force that propels the lawnmower forward. You're just looking for this component right here, right? There's no friction, so you know you're looking for sigma sigma Fx, because that's the component that pushes it forward, is equal to Fax. That's the only force that you see in the x direction. Now you come back and ask yourself, let's move this pad a little closer to me. I'm kind of wonky wonk tonight. So now you come back over here and you ask yourself, okay, that's sigma Fx, so what comes next? Sigma Fx equals ma, right? It says we're going to move forward, find the component of force that moves forward. So we're just looking for Fax, which you know is F cosine theta, right? Which gives us Fax equals, how much did you push with? 175. 175. Let's undo that. Right, what you know is 175 times cosine of 30, right? Put that in the handy dandy calculator. Let's do in degree mode. So we're going to do 175 times cosine of 30. Clear it. Let's do 30 cosine times 175, and that should give me 151. I'm going to slide it over here. 151. What was that answer? 151.55. 151.55 newtons, right? It's messy, but it gets the point. Okay? So now the pen's acting silly. I don't know why. So let's do a quick check over here real quick. Number 4 should be 117. So it's at 17.3 newtons. Well, let's go back and see what's going on. Oops, I'm sorry. You push a 775 newton lawnmower. The FA is really 20 newtons down. So all this should have been, right, let's make this bigger. Let's make this eraser. this should have been, come over here, get back over here, FAX should have been equal to 20 cosine of 30, which is equal to, calculator, 30 cosine times 17 times 20 should give me 17.32, which is the correct answer. So my FA turns out to be 17.32. Now let's go back and look, resume, and let's look at the mass. We know we got a sigma fx. Let me move over here just in case. Sigma fx equals ma. Well, but let's go back and do it the right way. Should be f, it should be f subscript a subscript x. So we know when we hit enter, that should be sigma fx subscript x should a subscript x, sorry, sigma fx is equal to max, right? So you know now, oops, back the bus up. You know now that should be sigma f subscript x, sorry, back up, by transitive property, sigma fx equals fxx equals max. Now we know sigma, you know, f subscript a subscript x should equal to max, right? Because we need to find that acceleration. Now, return, you know that this says, from your previous calculations, which we did on this horrible screen that I erased, should be 17.72, right? So let's go back here. You know that was 17, sorry. You know that was 17.32. Let me confirm that just to make sure. 17.32, right? Equal to ma, and that's going to be max. You know, I like to switch it around to make it what? Symmetric property. Right? Oops, sorry. You know, I'm going to do this. We're going to switch it around. Delete. Let that equal to 17.32. Got to go back and ask yourself, what was the mass? The mass was 175 Newton lawnmower. So before we do anything else, we got to go back and calculate that mass. That mass is 175 Newton lawnmower. Remember FG. Remember FG equals to mg, right? Which means that our 175 Newton lawnmower, right? Slap a negative sign in front of it because why? It's going down. That should be negative, right? Equal to m, right? You know that g is what? Sorry, I just lost the screen for a second. That G should be what? Negative 9.8, right? Negative 9.8. So if we solve for M, we get 17.857 for the mass. For the mass. Now go back up here. You know the FAX component was 17.32. MA equals 17.32. So now we're going to copy this, bring it down here, Control V, hit enter, hit a Control V, and in place of mass, I'm going to put in 17.86 because we're going to round it, right? 17.86. Right? Now we're going to take that guy and we're going to solve it for A. Therefore, my acceleration should be 0.97, right? Meters per second squared. The reason why we went through all that was because remember the question says how long does it take to accelerate the more from rest to 2.0 meters per second. So let's go back here to our problem. Come back here. We know we're going to do we have our big 6. Don't forget your big 6. We know we have a x sub naught equals 0. Hit enter. You know we're going to have a x sub f equals question mark. Do we know how far it goes? Let's check and see. Nope, it just asks us how long does it take it to accelerate from rest to 2 meters per second. So let's go back. So we don't know how far it goes. Leave that guy blank. Let's make this guy here subscript. That's a question mark. Hit enter. So what else is next? We're gonna need some V naught, right? There we go. Subscript that bad boy. Z naught equals starting from rest. So that's what? 0 meters per second. Hit enter. You know I want V sub F equals. The question says how long does it take to accelerate to 2 meters per second? So now we're going to go 2.0 meters per second. Right? Now we're going to do what? Oh, hey, we need some acceleration. But guess what? We just calculated the acceleration. 0.97. Hey, enter. And then we need time. I think the question was how long does it take? Right? Equals question mark. I need an equation that does not have an xf but has a t. So I think I'm going to try the baby equation. Let's see what we get. V sub f equals V sub naught. So now we're going to do what? Substitute in our variables. What do we know? Vf is what? 2, right? We know our V naught is what? 0 plus, what's our acceleration? 0.97 t. Solve for t. We know our time should be 2.061. Let's see how close we got. Time should be 2.06 seconds. Cool. This is going to be a little rough, messy video, but I didn't want to take the time to go back and edit it. So let's go ahead and throw it out there now because people can be using it now. I can go back and edit later. Thanks. Don't forget that fx equals fax from that first part of the video.